So in this video you are going to learn how to calculate percent yield. Percent yield is something that is usually calculated during a laboratory, during the analysis section. And percent yield and theoretical yield often confuse students. Theoretical yield is the stoichiometry calculations that we have been doing already in class, where you're theoretically predicting how much of something can be produced. Percent yield is taking that theoretical calculation and it's looking at what was actually made during the lab, and it's figuring out, okay, percent wise, how much did I make compared to what I could have made in theory. So a percent yield calculation, if you're asked to calculate one, it's always going to involve a stoichiometry calculation. You need to do the stoichiometry calculation before you can actually calculate the percent yield. And then you can actually calculate the percent yield. So percent yield is just actual yield divided by the theoretical yield. This actual yield is what was made in the lab. So this value, especially during a test or a quiz or a homework problem, has to be given to you because you aren't actually going to produce anything in that homework assignment and go over to the scale and weigh it out. In the lab, you would weigh out what you made, and then you'd calculate theoretically what you could have made to calculate the percent yield. So let's look at this problem. So we have our balanced chemical equation up here. In a lab, a student adds 2 moles of oxygen gas to excess hydrogen gas to produce 3 moles of water. Using the above reaction, calculate the percent yield of water. Alright, so we know it's going to be a two-step problem. We have to calculate the theoretical yield, which is stoichiometry, and then we can calculate the percent yield. It's a lot of terminology. So take the time you need to figure out what the words mean. And then the other part is that you're given 2 numbers. So students often look at these 2 numbers and they can't figure out which one they need to, quote unquote, if you will, do the stoich to, and which one is the actual yield. So the way to figure that out is that one of these numbers is always going to be on the reactant side. That's what went into the beaker or went into the test tube to make the product. The other number is always going to be one of the products. So the number that's one of the products that's on the right hand side of the reaction is the actual yield. So let's look. We have 2 moles of oxygen. That's a reactant. Oops. So we know 2 moles of oxygen gas went into it. The other number we produced, that's a key word there, we produced 3 moles of water. And water's on the product side. So we produced 3 moles of water. That's what was actually made. So one of the numbers is always on the product side. The number that's on the product side is always the actual yield. That's the number that we're going to save for last. The number that's on the reactant side is the number that went in, and that's the number that we're going to theoretically calculate how much should be made if we put that much into the beaker. That's the number that we're going to do the stoich to. Alright, so we have 2 moles of O2. We're going to set that up. We want water. It's a 2-to-1 ratio, 2 H2Os for every 1 oxygen. If we do the math, 2 times 2 divided by 1, we end up with 4 moles of water. That's our theoretical yield. That's how much we should have made. We actually made 3 moles. So now we can calculate the percent yield using this equation. So percent yield maybe. Percent yield, actual yield, we actually made 3 moles over 4 moles. That's what should have been made in an ideal world. And we are going to multiply that by 100 to get our percent. 3 divided by 4 is 0.75 times 100 gives us a percent yield of 75%. So that's how you calculate percent yield.